Now, in this lecture, you'll find out the area of the green shape using two different methods. In the drawing, we have a quarter circle. AOB is a quarter circle. Inside this quarter circle, we have quadrilateral ACDO. And we have to find out the area of the green quadrilateral AODC. In addition, we know that the side AC of quadrilateral ACDO is equal to 24 units in its length. Side CD of the quadrilateral is equal to 7 units in its length. And this angle ACD equals to 90 degrees. Our mission is to find out the area of the green quadrilateral ACOD. Okay. So first of all, because of the fact that AOB is a quarter circle, it means that this angle AOB must be equal to 90 degrees. This angle equals to 90 degrees, its size. And this point O, is the center of the circle that we can create by completing this quarter circle to a circle. Okay. So from the center of the circle, that is to say from point O, we go perpendicular on chord AC. So this angle equals to 90 degrees, and this angle also equals to 90 degrees according to our construction. We define the touching point of the perpendicular from point O and AC is P. Here we have rule number 11. According to rule number 11, the perpendicular to a chord drawn from the center of the circle bisects the chord. Point O is the center of this circle. Point O, we draw perpendicular OM on chord AB. That is to say, this angle equals to 90 degrees and this angle equals to 90 degrees according to our construction. Then, according to this rule number 11, the perpendicular OM will also bisect chord AB. That is to say, AM equals to MB. Okay, so we can implement rule number 11 in our drawing. Why? Because in our drawing, we have from point O, that is the center of the circle, we draw perpendicular on chord AC. Therefore, according to rule number 11, the perpendicular OP will also bisect chord AC. That is to say, AP equals to PC according to rule number 11. That is to say, AC has been bisected into two halves. The first half is AP and the second half is PC. Because of the fact that AC in total equals to 24 units according to what is given in the equation, it means that the first half will be 24 over 2, that is 12. And the second half will be also equals to 12 units, of course. So actually we implemented in this drawing rule number 11. Okay. In the next step, from point D, we draw perpendicular to PO. So actually, this angle equals to 90 degrees and this angle equals to 90 degrees according to our construction. We define the touching point of the perpendicular from point D and PO as Q. We actually created here quadrilateral PCDQ. Inside this quadrilateral PCDQ, we have 1, 2, 3 right angles. The sum of 3 right angles is 90 times 3 is 270 degrees. plus the size of this fourth angle. In total, the sum of those four angles must be equal to 360 degrees, according to the rule that the sum of the angles in any quadrilateral is equal to 360 degrees. Therefore, the missing angle here must be equal to 90 degrees. Repeat again, the missing angle here must be equal to 90 degrees. In order to complete the sum of the angles in this quadrilateral QPCD to 360 degrees, this missing angle must be equal to 90 degrees. So inside quadrilateral QPCD we have four right angles. Therefore, we will relate to quadrilateral QPCD as a rectangle. And we know that the opposite sides of a rectangle are equal to each other. That is to say, side PC must be equal to the opposite side QD, but PC equals to 12, therefore QD must be also equal to 12. Likewise, in rectangle QPCD, side DC must be equal to the opposite side QP, but DC equals to 7, therefore QP must be also equal to 7 units in its length. In the next step, we'll define the length of this line segment QO as x. QO equals to x according to our definition. We will focus on the right triangle OQD, and we will define angle ODQ as alpha. So in the right triangle OQD, this angle equals to alpha. This angle equals to 90 degrees, therefore the missing angle here must be equal to 90 degrees minus alpha. Why? Because 90 degrees minus alpha plus alpha is 90 degrees, and 90 degrees plus 90 degrees, it is equal to 180 degrees. That is the sum of the angles in any triangle. So this angle must be equal to 90 degrees minus alpha, but we will define 90 degrees minus alpha as beta. And therefore, this angle will be equal to beta. Angle AOB, the big angle AOB equals to 90 degrees, minus angle beta, it must be equal to the missing angle AOP. So angle AOP must be equal to the big angle that is AOB is 90 degrees, minus this angle that is angle beta. 90 degrees minus beta equals to the missing angle AOP, this angle AOP. So 90 degrees minus beta. Beta is 90 minus alpha, therefore we'll substitute beta here by 90 degrees minus alpha. We'll open the brackets here. 90 degrees minus 90 degrees is 0, and minus times minus is plus, so in total this expression equals to alpha. In conclusion, found out that the missing angle AOP, equals to alpha. This angle AOP equals to alpha. So we'll focus on the right triangle APO. In the right triangle APO, this angle equals to alpha, this angle equals to 90 degrees. Therefore, the missing angle must be equal to 90 degrees minus alpha. But 90 degrees minus alpha equals to beta according to our definition. Therefore, this angle will be equal to beta. In the next step, we'll focus on the right triangle OQD. So I'll copy the right triangle OQD in the new page, and we'll find out the value of tangent alpha in this right triangle OQD. So the right triangle OQD, copy it here. So actually this is the right triangle OQD that I copied from the original drawing. OQ equals to x according to our definition. QD equals to 12. So in this right angle QD or QD, we'll get the tangents alpha. This angle equals to alpha. So therefore tangents alpha will be equal to OQ over QD. Again, tangents alpha equals to OQ over QD. OQ equals to X and QD equals to 12. So in conclusion, found out that tangents alpha equals to X over 12. Okay. Tangents alpha equals to X over 12. In the next step, we will focus on the right angle APO. So I copy the right angle APO, and you will find out the value of tangents alpha in this right angle APO. So I copy the right angle in the new page. Side AP equals to 12 units. What is the length for side PQ? From the domain it is very easy to see that PO equals to PQ plus QO. That is to say, PO equals to PQ, that is 7, plus QO, that is X. So in total PO equals to X plus 7. So I write it down. PO equals to X plus 7. So this is actually the right angle APO that I copied from the original drawing. This angle equals to alpha. So this angle equals to alpha. So in this right angle APO, we get that tangents alpha equals to AP over PO. AP equals to 12 and PO equals to X plus 7. So in conclusion, found out that according to equation number 2, tangents alpha equals to 12 over X plus 7. Well, according to equation number 1, we have already found out that tangents alpha equals to X plus tangents alpha equals to X over 12. So we have two different expressions for tangents alpha. In the next step, we'll create equation number 3. According to equation number 3, tangents alpha, according to equation number 1, must be equal to tangents alpha, according to equation number 2. Okay? So, tangents alpha, according to equation number 1, equals to X over 12, and it must be equal to tangents alpha according to equation number 2. Tangents alpha according to equation number 2 equals to 12 over X plus 7. So in conclusion, we found out that according to equation number 3, X over 12 equals to 12 over X plus 7. Here we cross multiply this equation, and we get that according to equation number 3, this equation, X times X plus 7 equals to 12 times 12, that is 144. Here we'll open the brackets of this on this side of the equation number 3, and we get that according to equation number 3, X times X is X squared plus 7X equals to 144. Here we subtract 144 from this equation, and we get that X squared plus 7X minus 144 equals to 0. This is a quadratic equation, and then the general formula for a quadratic equation is ax squared plus bx plus c equals to 0. Here in this formula, a, b, and c are the coefficients of the quadratic equation, and x is the variable that we are looking for. And we find out the value of x according to a special formula. X equals to minus b plus minus the square root of b squared minus 4 times ac over 2a. Okay. Here also a, b, and c are the coefficients of this quadratic equation. In our specific quadratic equation, x squared plus 7x plus 144, the coefficient a equals to 1, the coefficient b equals to 7, and finally the coefficient c equals to minus 144. Now we will put the data inside this equation in order to find out the value of x. I remind to you that x is the length of this line 7 QO. So we are looking for the length of line 7 QO is equal to x. So we get that the value of x according to this special formula will be equal to minus b. b is 7, therefore minus b is minus 7, plus minus the square root of b squared. b is 7, so b squared is 7 squared, that is 49, minus 4 times a is 1, times c is minus 144, over 2a. a is 1, so 2 times 1 is 2. So we already found out that x equals to minus 7, plus minus 4 times minus 144 is plus 576 plus 49. In total it is equal to 625. So inside the root we left only with 625 over 2. So actually we found out here that x equals to minus 7 plus minus the square root of 625 is 25 over 2. Okay. X equals to minus 7 plus minus 25 over 2. So here we have two solutions that are possible for x. The first solution for x is x equals to minus 7 minus 25 over 2. Minus 7 minus 25 is minus 32. Minus 32 over 2 is minus 16. So in conclusion, we found out that x equals to minus 16. But because of the fact that x is the length, and the length must be a positive number, we cancel this solution. X cannot be a negative number. And we're left only with the second solution that is possible for x. The second solution for x is x equals to minus 7 plus 25 over 2. 25 minus 7 is 18. And 18 over 2 equals to 9. So finally we found out that x equals to 9 units. So here x is the length of this line segment QO. This equals to 9 units. So our mission is to find out the area of this green shape. We will divide the area of the green shape into 3 parts. The first part will be the area of the right triangle APO. We will define the area of the right triangle APO as A1. The second part of the green shape will be the area of the right triangle OQD. We define the area of the right triangle OQD as A2. And finally, the third part of the green shape will be the area of rectangle PCDQ. We define the area of the right triangle. We define the area of rectangle QPCD as A3. And from the drawing it is obvious that the area of the green triangle, the area of the green shape in total equals to A1 plus A2 plus A3. That is actually the area of the two right triangles APO plus the right triangle OQD plus the area of rectangle PQCD. So write it down. The area of the green shape in total will be equal to A1 plus A2 plus A3. We'll calculate each area separately and then we'll add the areas that will give us the area of the green shape. Repeat again that A1 is the area of the green right triangle APO. So I copy the green right triangle APO here in the new page and you find out the area of this green right triangle APO. Side AP of the green triangle APO is 12 units. PO, we already found out that PO equals to 7 plus X and X is 9. So in total PO equals to 7 plus 9, that is 16. So A1 equals to the area of this right triangle APO that I copied from the original drawing. The area of this right triangle APO equals to AP, that is the base, times PO, that is height to the base, over 2. AP equals to 12, PO equals to 16 over 2. 16 over 2 is 8, so in total this expression equals to 8 times 12, that is 96. So in conclusion, found out that A1 equals to 96 square units. I'll write it here. A1 equals to 96 square units. In the next step, we'll find out the area of A2, and the area of A2 equals to the area of the right triangle OQP. So I'll copy the right triangle OQP in the new page, and we'll find out the area of this right triangle OQD. This is the area of the right triangle OQD. Side OQ equals to X, that is 9. QD equals to 12. So this is the right triangle OQD that I copied from the original drawing. And this is area A2. So the area of the right triangle equals to the base, that is QD, times the height to the base, that is QO, over 2. QD equals to 12 units, times QO is 9 over 2. 12 over 2 is 6, so in total this expression equals to 6 times 9, that is 54. In conclusion, found out that A2 equals to 54 square units. And finally, we will find out the area of A3. A3 equals to the area of rectangle QPCD. The area of any rectangle equals to the length of the rectangle times the width. The length is PC times the width, that is QP. So the area of rectangle PCQD equals to PC times QP. PC is 12, QP is 7, so it is 12 times 7, that is 84. So found out that A3 equals to 84 square units. I repeat again that the area of the green shape equals in total to A1 plus A2 plus A3. We've already found out that A1 equals to 96 square units plus A2 that is 54 square units plus A3 that is 84 square units. 96 plus 96 plus 54 it is 150. Again 96 plus 54 it is 150, and 150 plus 84 it is 234. So in conclusion, found out that the area of the ring shape in total is equals to 234 square units. Okay, we finish with the first method. In the next step, I'll show you how to find out the area of this ring shape according to the second method. In the second method, we join points A and D together by a straight line. By joining points A and D together there, you created there the right triangle ACD. We will calculate the length of the hypotenuse AD in the right triangle ACD by implementing here the Pythagoras theorem. So I'll copy the right triangle ACD in a new page, and we will implement on this right triangle the Pythagoras theorem. So actually, this is the green right triangle ACD that I copied from the original drawing. Side AC equals to 24 units, side CD equals to 7 units, according to what is given us the question. According to the Pythagoras theorem in this right triangle ACD, here pi pt is the coefficient for Pythagoras theorem. AD squared, the square of the hypotenuse, must be equal to AC squared plus CD squared. So AD squared must be equal to AC squared. AC is 24, therefore AC squared is 24 squared, that is 576, plus CD squared. CD is 7, therefore CD squared is 7 squared, that is 49. In total, we found out that AD squared equals to 564 plus 49 is 625. So we take a root out of this equation and we get that AD equals to the square root of 625. It is actually 25. So we found out actually that the length of the hypotenuse AD is 25. So you can write here in the original drawing that this the hypotenuse AD of the right triangle ACD equals to 25 units in its length. In the next step, I remind you that point O is the center of the circle that we will create by completing the quarter circle to a circle. Right now we complete the quarter circle to a circle. So we completed this quarter circle to a circle. Point O is the center of this circle, point A is the point of the circle itself, therefore OA is the radius of this circle. We define the radius of this circle as R, so OA equals to R. We will extend the radius AO until it touches the circle. And we define the touching point of the extended radius AO and the circle as point M. Point O is the center of the circle, point M is the point on the circle itself, therefore OM is the radius of the circle, that is equal to R. Chord AM passes through point O, that is the center of the circle. Any chord that passes through the center of the circle must be the diameter of the circle. Therefore, AM is the diameter of the circle. AM is the diameter of the circle. And the length of AM is R plus R, that is 2R. Exactly as we expect from a diameter, it always must be twice as long as the radius. Okay, so we found out that AM is the diameter of the circle, that is equal to 2R. In the next step, we will extend side CD until it touches the circle. But the real question is where the extended side D will touch the circle. We will assume that the extended side D will not touch the circle at point M, but in any other point. For example, we'll assume that the extended side CD will touch the circle at this point, point N. Okay. We should remember that AM is the diameter of the circle. So here we get that peripheral angle ACN. This is peripheral angle ACN, and it is equal to 90 degrees according to what is given in the question. Peripheral angle ACN that is equal to 90 degrees rests on AN, and AN is not the diameter of the circle. Again, peripheral angle ACN rests on AN, that is not the diameter of the circle. And this is contradiction to rule number 5. Why? Because according to rule number 5, any peripheral angle that is equal to 90 degrees must rest on the diameter of the circle. Here, this peripheral angle MAN equals to 90 degrees, and this angle MAN, peripheral angle MAN rests on MN, that is the diameter of the circle. And the angle ACN is also equals to 90 degrees, and according to rule number 5, this angle ACN must rest on AM, that is the diameter of the circle. But according to our assumption, if the extended side CD touches the circle at point N, then the peripheral angle ACN will rest on AN, that is not the diameter of the circle, and this is contradiction to rule number 5, because peripheral angle ACN equals to 90 degrees, and therefore it must rest on AM, that is the diameter of the circle. Okay, due to the contradiction to rule number 5, we must conclude that the extended side CD must touch the circle at point M, and only at point M, and not in any other point. Otherwise, we get contradiction to rule number 5. Okay, so we will extend side CD, and side CD, the extended side CD, definitely touch the circle at point M and not in any other point. So here we'll get that peripheral angle ACM equals to 90 degrees, and it obeys to rule number 5 in the sense that it rests on AM, that is the diameter of the circle, exactly according to rule number 5. Okay? So CDM is one straight line because we extended side CD by straight line. We got this line 7 CDM, that is one straight line. In the next step, we will focus on this side of the diameter AM at point O. First of all, because of the fact that AOB is a quarter circle, this angle must be equal to 90 degrees. We'll focus on this side of the straight line of the diameter AM. That is, as a diameter, it is absolutely a straight line. So on this side of the straight line AM at point O, the sum of the angles must be equal to 180 degrees, according to the rule that the sum of the angles the sum of the angles on one side of a straight line is equal to 180 degrees. So which angles we have at this side of AM at point O? We have this angle that is equal to 90 degrees plus the missing angle. In total, it must be equal to 180 degrees according to the rule that I mentioned. Therefore, the missing angle here must be equal to 90 degrees. In order to complete the sum of the angles on this side of the straight line AM at point O to 180 degrees, this missing angle must be equal to 90 degrees. In the next step, we will prove that the right green triangle AON is congruent to the right green triangle MOD. So write it down, the right green triangle AOD is congruent to the right white triangle MOD. So why those two right triangles can go into each other? First of all, side AO of the green triangle is equal to side OM of the white triangle. Repeat again. Side AO of the green triangle equals to side OM of the right triangle. They are both the radii of the circle, therefore they are equal to each other. In addition, those two angles are both equal to 90 degrees, therefore they are equal to each other. So, angle AOD in the green triangle equals to angle MOD in the white triangle. Repeat again, angle AOD in the green triangle equals to angle MOD in the white triangle. They are both equal to 90 degrees, therefore they are equal to each other. And finally, those two triangles have a common side. Side OD is a common side. It belongs to both triangles. So we can write down that OD equals to itself as a common side. Repeat again. OD equals to itself as a common side that belongs to both triangles. So actually succeeded to prove that those two right triangles can go into each other according to side angle side rule. Those two sides and the angle between those two sides in the green triangle corresponding can go into those two sides and the angle between those two sides in the white triangle. Therefore, those two right triangles can go into each other according to side angle side rule. Triangle, the green triangle AOD, congruent, this is the sign of congruent, to the white triangle, triangle MOD, according to side angle side rule. And from the fact that those two right triangles can go into each other, we will derive that side AD of the green triangle equals to side DM of the white triangle. AD equals to DM. Repeat again. We will derive that AD equals to DM. AD equals to DM according to the rule that corresponding sides and congruent triangles are equal to each other. Those two triangles can go into each other, therefore the two corresponding sides AD and DM must be also equal to each other. But AD equals to 25. So can I give that AD equals to 25? And from this equation 25 equals to 80 equals to dm, we derive that dm is also equals to 25. dm equals to 25. Here say dm equals to 25 units in its length. And therefore, in total, the length of the straight line CM, it is equal to CD plus DM. CM equals to CD, that it is 7, plus DM, that is 25. 7 plus 25 is 32. So CM in total equals to 32 units in its length. So copy the right triangle ACM and we will implement on this right triangle ACM the Pythagoras theorem. So actually, this is the right triangle ACM that I copied from the original drawing. As I already mentioned before, CM equals to 32 units, AC equals to 24 units according to what is given as the equation. And we already found out that AM is the diameter of the circle, that is equal to 2r, of course. Here by PT is abbreviation for Pythagoras theorem. In this right triangle, according to the Pythagoras theorem, we get that AM squared, that is the square of the hypotenuse, must be equal to AC squared plus CM squared. AM is 2r, so AM squared is 2r squared. 2r squared is 4r squared, and it is equals to AC squared. AC is 24, therefore AC squared is 24 squared, that is 576. Plus CM squared. CM is 32, therefore CM squared is 32 squared, that is 1024. So 4r squared equals to 1024 plus 576 equals exactly to 1600. So we found out that 4r squared equals to 1600. We divide this equation by 4 and finally we get that r squared equals to 1600 over 4 is 400. R squared equals to 400. We take a root out of this equation and we get that r equals to the square root of 400, that is 20. So the radius of this circle, r equals to 20. So we can write here that r equals to 20 units. In the next step, we'll implement the Pythagoras theorem on this right green triangle AOD. So I'll copy the right green triangle in a new page and we will implement on it the Pythagoras theorem. The hypotenuse AD equals to 25 units in its length. We just right now found that AO, the radius R equals to 20 units. The missing side is OD. We find out the value of the missing side OD by implementing the Pythagoras theorem on this right triangle AOD. Again, here by PT is the abbreviation for Pythagoras theorem. This is the right triangle AOD that I copied from the original drawing. According to the Pythagoras theorem in the right triangle AOD, we get that AD squared equals to AO squared plus OD squared. Okay, so AD squared, AD is 25, therefore AD squared is 25 squared, that is 625. And it is equal to AO squared. AO is 20, therefore AO squared is 20 squared, that is 400, plus OD squared. OD is the missing side, so we leave it as it is. We'll subtract 400 from this equation, and we get that 625 minus 400 is 225, that is equal to OD squared. Here we take a root out of this equation, And finally we get that OD equals to the square root of 225, that is actually 15. So I found out that the missing side OD in the green right angle AOD equals to 15 units in its length. Now it is very easy to see, to find out the area of this green shape. The area will be equal to the area of the green shape will be equal to the area of the green triangle, the green right triangle AOD. So we find the area of the green triangle AOD is A1 plus the area of the green right triangle ACD. So we define the area of the green triangle ACD as A2. So the area of the green shape in total will be equal to the area of the green right triangle AOD, that is A1, plus the area of the green right triangle ACD, that is A2. The area of the green triangle in total equals to A1 plus A2. We write it down. The area of the green shape in total, it will be equal to A1 plus A2. A1 is the area of the green right triangle AOD, so I copy again the right triangle AOD here, and we find out the area of this green triangle, green right triangle AOD. So this is the green right triangle AOD that I copied from the original drawing. The area of this green triangle will be equal to the base of the triangle, that is OD, times the height to the base, that is AO, over 2. OD equals to 15, AO equals to 20, divided by 2. 20 times 15 is 300, and 300 over 2 is 150. In conclusion, we found out that the area A1 equals to 150 square units. That is to say, the area of the right triangle AOD, that is A1, equals to 150 square units. In the next step, we find out the area of A2, that is actually the area of the green right triangle ACD. So I copy the right green triangle ACD in the new page, and we find out the area of this green right triangle. AC equals to 24 units and CD equals to 7 units according to what is given us the question. So actually, this is the green right triangle ACD that I copied from the original drawing. And this is A2, the area A2. It is the area of the right triangle ACD. The area will be equal to the base of the triangle, that is CD, times the height to the base, that is AC, over 2. CD equals to 7, AC equals to 24, divided by 2. 24 over 2 is 12. So in total this expression equals to 12 times 7, that is 84. So in conclusion, found out that A2 equals to 84 square units. And we already found out that A1 equals to 150 square units. Repeat again. The area of the green shape equals to A1 plus A2. That is to say, it is equals to A1, that is 150, plus A2, that is 84. 150 plus 84 equals to 234. We found out that the area of the green shape, according to the second method, in total it is equals to 234 square units. Repeat again, the area of this green triangle the area of the green shape in total equals to 234 square units. So finish with the second method. In the next step, I will summarize the lecture. We'll start with the first method. In this lecture, we found out the area of this green shape. In the domain, we have a quarter circle. AOB is a quarter circle. And we also know that side AC of quadrilateral ACOB equals to 24 units in its length, side CD equals to 7 units in its length, and this angle ACD equals to 90 degrees. Our mission is to find out the area of quadrilateral ACOD. AOB is a quarter circle, therefore this angle AOB must be equal to 90 degrees, and point O is the center of the circle that we can create by completing this quarter circle to a circle. From point O, that is the center of the circle, we draw perpendicular towards chord AC. So this angle equals to 90 degrees and this angle equals to 90 degrees according to our construction. We define the touching point of the perpendicular from point O and AC is P. And here we have rule number 11. According to rule number 11, the perpendicular to a chord drawn from the center of the circle bisects the chord. Point O is the center of the circle. From point O, we draw perpendicular OM on chord AB. That is to say, this angle equals to 90 degrees and this angle equals to 90 degrees according to our construction. According to this rule number 11, the perpendicular OM is also bisect chord AB. That is to say, AM equals to MB. We can implement rule number 11 in our drawing. Why? Because in our drawing, from the center of the circle, that is to say from point O, we draw perpendicular OP on AC. Therefore, according to rule number 11, the perpendicular OP bisects chord AC. That is to say, AP equals to PC. In total, AC equals to 24. Therefore, AP will be the first half, that is 24 over 2, that is 12. The second half will be PC, that is also 12. So this is the implementation of rule number 11 in our drawing. AP equals to PC equals to 12. In the next step, from point D, we do perpendicular on PO. This angle equals to 90 degrees and this angle equals to 90 degrees according to our construction. We define the touching point of the perpendicular from point D and PO as Q. In this way, we created quadrilateral PCQD. Inside this quadrilateral, we have 1, 2, 3 right angles. This angle equals to 90 degrees according to what is given us in the question. So in total, we have 3 right angles. The sum of 3 right angles is 90 times 3 is 270 degrees, plus the fourth angle. In total, they must be equal to 360 degrees according to the rule that the sum of the angles in any quadrilateral is equal to 360 degrees. Therefore, the missing angle here must be equal to 90 degrees. So inside quadrilateral PCQD, we have 4 right angles. Therefore, we can relate to quadrilateral PCQD as a rectangle. And we know that the opposite sides of a rectangle are equal to each other. That is to say, side PC must be equal to the opposite side QD. But PC is 12, therefore QD must be also equal to 12. Likewise, in rectangle PQDC, side CD must be equal to side PQ. But CD equals to 7, therefore PQ must be also equal to 7. In the next step, we defined the length of this last element QO as X. Then we focused on the right triangle OQD. In this right triangle, we defined angle QDO as alpha. This angle equals to alpha. This angle equals to 90 degrees. Therefore, the missing angle here must be equal to 90 degrees minus alpha Why? Because 90 degrees minus alpha plus alpha is 90 degrees, and 90 degrees plus 90 degrees, it is equal to 180 degrees. That is the sum of the angles in any triangle. But we defined, so this angle equals to 90 degrees minus alpha, but we defined 90 degrees minus alpha is beta, so therefore this angle is beta. In total, angle AOB equals to 90 degrees. So angle AOB minus angle beta equals to the missing angle AOP. Again, angle AOP equals to 90 degrees minus beta. So it is 90 degrees minus beta, but beta equals to 90 degrees minus alpha. So we can substitute beta by 90 degrees minus alpha. We open the brackets here. 90 degrees minus 90 degrees is 0, and minus times minus is plus. So in total, this expression equals to alpha. Okay, so the missing angle here, angle AOP equals to alpha. We will focus on the right angle AOP and the right angle AOP. This angle equals to alpha. This angle equals to 90 degrees. Therefore, the missing angle here must be equal to 90 degrees minus alpha. But 90 degrees minus alpha is beta. So this angle equals to beta. Then we focus on the right triangle OQD. So I copied the right triangle OQD in a new page, and we found out the value of tangent alpha here. This is the right triangle OQD that I copied from the original drawing. OQ equals to x and QD equals to 12, and this is angle alpha. This right triangle OQD, tangent alpha equals to QD, tangent alpha equals to QO over QD. Tangent alpha equals to QO over QD. QO equals to x and QD equals to 12. So in total, we found out actually the tangent alpha equals to x over 12. Then we focus on the right triangle APO, so I call it the right triangle APO in a new page, and we found out the value of tangent alpha in this right triangle also. This is the right triangle APO that I copied from the original drawing. This is angle alpha. AP equals to 12. What is the value of PO? From the drawing, it is very easy to see that PO in total equals to PQ plus QO. That is to say, PO equals to PQ, that is 7, plus QO, that is x, so in total PO equals to x plus 7. PO equals to x plus 7, AP equals to 12, and this is angle alpha. So in this right triangle APO, we'll get that tangent alpha equals to AP over PO. Again, tangent alpha equals to AP over PO. AP is 12 and PO is x plus 7, so in total I found out that according to equation number 2, tangent alpha equals to 12 over x plus 7, while according to equation number 1, we already found out that tangent alpha equals to x over 12. So we have two different expressions for tangent alpha. Therefore, we can create equation number 3 that states we can create equation number 3 that states that tangent alpha according to equation number 1 must be equal to tangent alpha according to equation number 2. Tangent alpha according to equation number 1 equals to x over 12. And it must be equal to tangent alpha according to equation number 2. Tangent alpha according to equation number 2 equals to 12 over x plus 7. So in conclusion, found out that according to equation number 3, x over 12 equals to 12 over x plus 7. We cross multiply this equation and found out that x times x plus 7 equals to 12 times 12, that is 144. We opened the brackets on this side of equation number 3 and found out that x times x is x squared plus 7x equals to 144. We subtracted 144 from this equation and finally found out that x squared plus 7x minus 144 equals to 0. So we have here a quadratic equation. And the general formula for a quadratic equation is ax squared plus bx plus c equals to 0. Here, a, b, and c are the coefficients of the quadratic equation, and x is the variable that we are looking for. And we find out the value of x according to this special formula. X actually equals to minus b plus minus the square root of b squared minus 4 times ac over 2a. Here also a, b, and c are the coefficients of this quadratic equation. In our specific quadratic equation x squared plus 7x minus 144, the coefficient a equals to 1, the coefficient b equals to 7, and the coefficient c equals to minus 144, a, b, and c. So we put the data inside this equation in order to find out the value of x. I We remind to you that x, according to our definition, x is the length of line segment QO. So x, according to this equation, x equals to minus b. B is 7, so minus b is minus 7, plus minus the square root of b squared. B is 7, therefore b squared is 7 squared, that is 49, minus 4 times AC. A is 1, so minus 4 times 1 times C, that is minus 144 over 2A. A is 1, so 2A is 2 times 1, that is 2. So found out that x equals to minus 7 plus minus 4 times minus 144 is 576, plus 49, in total it is equal to 625. So inside the root we left only with 625. The square root of 625 is 25. Therefore in total we actually found out that x equals to minus 7 plus minus 25 over 2. So here we have two solutions that are possible for x. The first solution for x is x equals to minus 7 minus 25 over 2. Minus 7 minus 25 is minus 32, and minus 32 over 2 is minus 16. You can find out that the value of x is minus 16, but because of the fact that x is the length, and the length must be a positive number, we cancel this solution for x, that is a negative number, and we left only with the second solution that is possible for x. The second solution for x is x equals to minus 7 plus 25 over 2. 25 minus 7 is 18, and 18 over 2 is 9. So in conclusion, found out that the value of x is 9. Here, x, that is the length of line segment QO, equals to 9 units. And we are looking to find out the area of this green shape. We divided the green shape into 3 parts. The first part is the right triangle APO. We define the area of the right triangle APO as A1. The second part of the green shape is the right triangle OQD. We define the area of the right triangle OQD as A2. And finally, the third part of the green shape is rectangle PCQD. We define the area of the rectangle PCQD as A3. And it is obvious from the drawing that in total the area of the green shape must be equal to A1 plus A2 plus A3. That is actually the area of the two right triangles APO and OQB and QDO plus the area of rectangle PCQD. So here the area of the green shape equals to A1 plus A2 plus A3. A1 is the area of the right triangle APO. I copied the right triangle APO here. Side AP equals to 12 units in its length. PO equals to 7 plus x, but x is 9. Therefore in total PO equals to 7 plus 9, that is 16. And PO equals to 16 units in its length, and AP equals to 12. So the area A1, that is the area of this right triangle APO, must be equal to AP times PO over 2. AP is 12, PO is 16 over 2. 16 over 2 is 8, so in total this expression equals to 8 times 12. 8 times 12 is 96. So in conclusion, we found out that the area A1 equals to 96 square units. Then we found out the area of A2. A2 is the area of the right triangle QOD. So I copied the right triangle QOD here from the original drawing. QOD equals to 12 units in its length, and QO is x, and x equals to 9. So the area of this right triangle QOD is A2. What is the area of this right triangle QOD? It is equals to QD times QO over 2. QD is 12, QO is 9 over 2. 12 over 2 is 6, so in total this expression equals to 6 times 9. 6 times 9 is 54. In conclusion, found out that A2 equals to 54 square units plus A3. A3 is the area of rectangle PCQD. The area of any rectangle is the width of the rectangle times the length. The width times the length. The width is PQ, that is 7, and the length is PC, that is 12. I will repeat again. PQ times PC. Okay. PC is 12 and PQ is 7. Okay, here it is PC. PC is 12 and PQ is 7. 12 times 7 is 84. So in conclusion, we found out that A3 equals to 84 square units. And the area of the green shape in total equals to A1 plus A2 plus A3. A1 equals to 96, A2 equals to 54, and A3 equals to 84. 96 plus 54 is 150, and 150 plus 84 is 234. In conclusion, we found out that the area of the green shape equals to 234 square units. We finished with the first method, and I presented to you how to find out the area of this green shape according to the second method. In the second method, we joined points A and D together by a straight line. In this way, created the green right triangle ADC. Implemented the Pythagoras theorem on this right triangle ADC in order to find out the length of the hypotenuse AD. So this is the green right triangle ADC or ACD that I copied from the original drawing. AC equals to 24, CD equals to 7. The only missing side is the hypotenuse AD. According to the Pythagoras theorem, in this right triangle ADC, AD square equals to AC square plus CD square. So AD square equals to AC square. AC is 24, therefore AC square is 24 squared, that is 576 plus CD square. CD is 7, therefore CD square is 7 square, that is 49. So AD square in total equals to 576 plus 49, that is actually 625. AD square equals to 625. We took out of this equation and found out that AD equals to the square root of 625, that is 25. So the length of this hypotenuse in the right triangle ACD equals to 25 units. Then we did the construction and completed the quarter circle to a circle. And we want to that AOB is a quarter circle, therefore this angle equals to 90 degrees, and AOB equals to 90 degrees, and point O is the center of this circle. Okay. We join points, point O is the center of this circle, point A is the point of the circle itself, therefore AO is the radius of this circle that we defined as R. Then we extended the radius AO until it touches the circle at point M. Point O is the center of the circle, point M is the point of the circle itself, therefore OM is also the radius of this circle that is equal to R according to our definition. Okay, and because of the fact that AM is a chord that passes for point O, any chord that passes for the center of the circle, that point O is the center of the circle, any chord that passes for the center of the circle must be the diameter of the circle. Therefore AM is the diameter of the circle, and AM equals to R plus R, that is 2R. AM, that is the diameter of the circle, equals to 2R. Then we extended side CD until it touches the circle. We assumed that the extended side CD will touch the circle at point N. But it is impossible. Why? Because angle ACN equals to 90 degrees according to what is given as the equation. It is a peripheral angle that is equal to 90 degrees, and according to rule number 5, any peripheral angle that is equal to 90 degrees must rest on the diameter of the circle. MAN is a peripheral angle that is equal to 90 degrees, and therefore it rests on MN, that is the diameter of the circle. And therefore here, peripheral angle ACN that is equal to 90 degrees must rest on AM. But peripheral angle ACN rests on AN, that is not the diameter of the circle. It is the contradiction to rule number 5. In order that we will not have any contradiction to rule number 5, we must conclude that the extended side CD must touch the circle at point M and only at point M and not in any other point. Okay, so here we get that peripheral angle ACM that is equal to 90 degrees indeed rests on AM, that is the diameter of the circle, exactly according to rule number 5. Okay, so CDM is one straight line, because we extended side CD by straight line, the result CM is a straight line. So this angle equals to 90 degrees, AM is the diameter, AM is the diameter, it is absolutely a straight line. If you focus on this side of the straight line AM at point O, this angle equals to 90 degrees, plus the missing angle, in total they must be equal to 180 degrees, according to the rule that the sum of the angles on one side of a straight line is equal to 180 degrees. Therefore the missing angle must be equal to 90 degrees. In order to complete the sum of the angles of this side on the straight line AM at point O to 180 degrees, the missing angle here must be equal to 90 degrees. Then we proved that the right green triangle ADO can go into the right white triangle or DM. Why those two right triangles can go into each other? First of all, AO equals to OM. They are both the radii of the circle, therefore they are equal to each other. Again, AO equals to OM, they are both the radii of the circle, therefore they are equal to each other. In addition, those two angles are both equal to 90 degrees, therefore they are equal to each other. Angle AOD equals to angle MOD, they are both equal to 90 degrees, therefore they are equal to each other. And finally we have side DO, that is a common side that belongs to both triangles, so side DO equals to itself, it's a common side that belongs to both triangles. So OD equals to this, a common side that belongs to both triangles. So we actually succeeded to prove that those two right triangles, the green triangle is going to the white triangle according to side angle side rule. Those two sides and the angle between them is the green triangle, and correspondingly can go into those two sides and the angle between them is the white triangle. Therefore those two right triangles can go into each other according to side angle side rule, and from the fact that those two right triangles can go into each other, we will derive that side AD in the green triangle equals to side DM in the white triangle. AD equals to DM according to the rule that corresponding sides in congruent triangles are equal to each other. Those two triangles can go into each other, therefore the corresponding sides AD and DM must be also equal to each other. But AD equals to 25. So can I tell that AD equals to 25, and from this equation 25 equals to AD equals to DM, we will derive that DM also equals to 25. Here, this side DM equals to 25 units in its length. CDM is one straight line, therefore in total CM equals to CD plus DM. That is to say CM equals to CD, that is 7, plus DM, that is 25. 7 plus 25 is 32. So in total CM equals to 32 units in its length. AC equals to 24, and the hypotenuse AM equals to 2R. So I copied the right triangle ACM in the new page and implemented on this right triangle ACM the Pythagoras theorem. This is the right triangle ACM that I copied from the original domain. We just right now found out that CM equals to 32. This is of course a straight line. AC equals to 24, and the hypotenuse AM equals to 2R, it is the diameter of the circle. In this right triangle, by PT's evolution from Pythagoras theorem, AD squared equals to AC squared plus CM squared. So AM is 2R. AM squared is 4R squared, and it is equal to AC squared. AC is 24, therefore AC squared is 24 squared, that is 576 plus 30 plus CM squared. CM is 32, therefore CM squared is 32 squared, that is 1024. So 4R squared equals to 576 plus 1024, that is in total 1600. So 4R squared equals to 1600. We divided this equation by 4 and finally found out that R squared equals to 1600 over 4 is 400. We took out of this equation and finally found out that R equals to the square root of 400, that is 20. So we found out finally that the radius of this circle R equals to 20 units in its length. Then I copied the right triangle and the right triangle AOD in a new page, and we implemented this right triangle AOD, the Pythagoras theorem, in order to find out the missing side OD. This is the right triangle AOD that I copied from the original domain. We have already found out that the hypotenuse AD equals to 25 units in length. AO is the radius of the circle that is equal to the radius of the circle that is equal to 20 units in its length. OD is the only missing side. According to the Pythagoras theorem, in this right triangle, AD squared equals to AO squared plus OD squared. AD is 25, therefore AD squared is 25 squared, that is 625, plus AO squared. AO is 20, therefore AO squared is 20 squared, that is 400, plus OD squared. OD is the missing side, so we leave it as it is. We subtract the 400 from this equation, and finally found out that 625 times 400 is 225. So in conclusion, we found out that OD squared equals to 225. We took out of this equation and finally found out that OD equals to the square root of 225. The square root of 225 is 15. So in conclusion, we found out that OD, the missing side OD equals to 15 units in its length. This side OD equals to 15 units in its length. What is the area of the green shape? The area of the green shape equals to the area of the green right triangle AOD. We define the area of this green triangle AOD as A1 plus the area of the green right triangle ACD. We define the area of the green right triangle as A2. So in conclusion, we found out that it is obvious from the domain that the area of the green shape equals to A1 plus A2. The area of the green shape equals to A1 plus A2. A1 is the area of the right triangle AOD. I copied the right triangle AOD here. AO is 20, OD is 15. So the area of this right triangle AOD equals to OD times AO over 2. OD is 15, AO is 20 over 2. 15 times 20 is 300, and 300 over 2 is 150. So in conclusion, found out that the area of the right triangle AOD, A1, is 150 square units, plus A2. A2 is the area of the right triangle ADC, so I copy the right triangle ADC here. According to what is given as the equation, AC equals to 24 and CD equals to 7. Therefore, A2 is the area of this right triangle ACD. The area of this right triangle ACD equals to DC times AC over 2. DC is 7, AC is 24, divided by 2. 24 over 2 is 12, so in total this expression equals to 12 times 7. 12 times 7 is 84. So in conclusion, we found out that 84 equals to 84 square units. That is the area of this right triangle ACD. And we have found out that A1 equals to 150 square units. I remind you that the area of the green shape equals to A1 plus A2. A1 is 150 plus A2, that is 84. 150 plus 84, it is 234. In conclusion, we found out that the area of this green shape equals to 234 square units. Okay, thank you very much.